No, I'm not laughing. I'm not laughing, but I'm laughing.
Is your computer not working?
I think the internet just started.
Because I have the next door. I have to press this button out there. It looks like it's on now.
Yeah, I think it's, yeah, it was out, so, okay, cool. So now I know what to do if it goes out. I'll go next door.
Thanks a lot.
Thanks, man. All right, so. Babylonian numbers are base what? 60, 11. And we discussed some things like this is effectively, why do you write so small, Jeff? That's effectively 0, right? There's 2 chisel marks on top of each other. Okay, I like it. So, it's base 60, so if I give you, now the book is a little evil. If the book does something like this, how many places are there?
2.
Good,
I know.
because those, so they like, if there's ever a 1 in front of a 10, that means that this is a place and this is a place. They really sometimes don't put enough space in between. It's a little evil. So what place is this? The 1 place? 60s. So how many 60s do I have?
2.
2.
So
And how many 1s do I have?
42.
22. So 2 60s plus 22 1s. 142. Stop for a minute.
You're going too fast, and I was like,
Okay. So this symbol, of course, means. What does that symbol mean?
10.
10. And this symbol means 1. And then this symbol, and remember, this is just the way I write it real quick. You're going to see in the book like that. Or like a flatter triangle, I think they make. Okay. I just put a line just to make it quick to draw, instead of drawing a bunch of triangles. This means is effectively 0, which is what I wrote up there. So if I saw this, how many places are there?
3.
3.
We have a 0 right there.
We have a placeholder. So we'll place, this is the
1.
1s.
60. 3600.
How did I get 30? How did you get 3600?
60 times 6.
Yeah, it's just times 60 every step, just like our system is times 10, 10 times 10, 100 times 10, 1,000.
Because there's a gap. I think I know what you did for that one, because there was a gap into each between, so therefore.
So let me draw it more like the book would draw it.
Basically.
There. That's how it would look in the book. But this is actually a little more in your face, obvious, because this means there's a place there, which means it's separating a place here and a place there. So when they do this, it's a little bit more evil.
There's like 10 there, but then there's a 1.
So what total is in this place then?
11.
11. In the 3600 place, and this is the 60s place, and this is the 1s place. So there's 11 3600s, no 60s.
No 60s. And 4 1s.
4 1s. 39604. Alright. Am I gonna get any help? No?
I'm doing it.
Thank you so much. I think it's 39604. I don't know if I touched my brain today. Or any day.
I got 39,604.
Yeah, look at Jeff go. It's my one skill. Gotta show it off. Is that there, or did you have a more specific question about them?
Yes, I do
Okay.
actually. For wait, it's in my notebook. I think it was on number 11, 11C, and 12B. 12 as placeholder.
This is section
2.2, set A.
11B. Okay, let's do this.
No, set A.
Set A, number
Number 11, like on the C
or C.
section,
Okay.
and then on 12B. Because I don't know what the Mayan numerals are, basically.
You need to.
Mm.
In Mayan, what's 1?
That's 1 dot.
So you know it. Okay, and what's 5?
That's a line.
Okay, so you gotta edit your earlier statement. You know them. You know the Mayan numerals. Do you mean you don't know the places?
Yes,
Okay.
that's the thing.
Okay. Alright.
Because I was struggling with the places yesterday while I was working on the homework with the tutor. Where?
Alright, so this one, wait a minute, part C, that's not Mayan.
Oh, no, the Mayan, I said 12B is numeral to Mayan. And then it was on L, and then C is Babylonian. That's what I was struggling with yesterday, with 12 and 11.
Yeah, why is 12 more difficult, everybody?
Because you have to do 2 problems in one, basically.
Yes! Isn't it evil? Don't math people love doing that? We love the multi-step problems. Like, ha ha. So like on part A, for example, I would first have to convert that Roman numeral to Hindu Arabic, and then I can go from Hindu Arabic to Babylonian. So that's like 2 problems in one. I love that. Okay. You would, Jeff. So, okay, so let's do this. Let's do a Mayan example. Well, let's do this. Let's do a Babylonian example the other way. So if I needed to convert, what do you got, Jeff? 3011 to Babylonian. Hey. You didn't call him Babaloo? Is that better than baby? I don't know.
Babaloo or Babaloo?
Babaloo. Alright. Why is this one harder than the one I just did on the board earlier? What's always going to be harder when we go from
1s to 60s?
our place to somebody else's?
Yeah.
It's always harder because it involves division and subtraction. Going from somebody else's to ours, most of the time it's multiplication and addition, sorry. So that's going to be easier. So what's my first step to do this? To change that Hindu Arabic number to Babylonian. What do I do first?
Well, we do need a placeholder because effectively the
No, stop. Those numerals are the idea of 3011. I have no idea if when I change them to Babylonian places and numerals that I'm going to need a 0. I don't know. Does that make sense? I don't know yet. Okay. Oh, I just kind of gave it away. What do I have to do first when I'm trying to convert this to Babylonian? How many places am I going to need? Do we know? Not yet. I got to write some down. Of course, the places are
3,600.
and you always want to do that. Trust me. That is going to save some of you from yourselves. If you go too far and cross it out, then you know you went far enough. That's the point. What's the next step?
finds out what's in the 1s place and in the 60s place.
Do I do it in that order? I always do it from bigger to smaller, right?
So the 3 is the bigger one.
No, stop. Bigger place. Bigger place. So how many 60s can I use to make most of this number? 60 goes into 3011. You guys are with me out there?
No.
Okay. So, the whole deal, when I'm trying to convert from hours to there, it is so much easier to figure out, let me see, this might be a good, yeah, I'm gonna do something similar to this with the manipulatives in a little bit. If I figure out how many big pieces I need first, and then the leftovers are where we go here. It's almost like dividing any regular number. Don't I find the remainder at the end? The ones place is like the remainder place. It's where all the extra little loose things go. I have to first figure out how many extra little loose things do I have. So I always have to work from the biggest place to the smallest. And just to show you an example, I mean, if I started with the ones, how would that even work? I don't have any clue how many ones I need because I don't know how many of those I have to use. I have to start with the bigger one. So what is 60 into 3011? 50. So if you do that, just do 3011 divided by 60.
That's 50.1.
Yeah, don't even worry about the point stuff. So I've taken care of 3,000 of that. In fact, remember last time I showed you a neat trick with the point stuff. Okay, stop for a minute. And you never have to use that neat trick with the point stuff if you don't want to. Yes?
Can you tell us again? So
If you do minus
I was
50.
trying to remember and I was like,
Do you have this in your calculator right now?
Yeah.
Now do minus 50. And then do times, what did he do? Times 60. You multiply it by what you divided by.
Wait,
What do you get?
11.
Yeah. And again, what did I just say? That's a neat little side note. You don't have to do it if you don't want to. I really want this to make sense. Watch, real quick. Would I write this like this? Yes? Isn't that decimal that you see in your calculator equal to 11 divided by 60?
Yep.
So what are you going to get when you multiply by 60? 11. That's why that works.
So the 11's in the 60s place.
No. The 11 is what's left over. All right, so let me take that away. 60 went into 3011 about 50 times, right?
Mm-hmm.
So we've taken care of 3,000 of this number. Does that make sense?
Yes.
50 60s is 3,000. So if I put 50 here, how much of the number do I still have to take care of? 11.
11.
So that's my leftovers. 50 60s plus 11 is 3011. I can see that right here. So we're really just capturing 50 of these and 11 ones makes the number, 3011.
The 60s would be the,
Now, of course, how do you write the answer? Is that the answer?
no.
The last thing I have to do is translate it, of course, into Babylonian symbols. 50 would look like what? 5 Pac-Men. 5 very angular Pac-Men. And then, of course, 11. Now, this is one I'd like to see how the book did this, because
Wait,
you know,
what
you have to have some
yeah.
space there, yeah.
Wait, that's a 10, right? Yeah.
Yes. So this is 50, right? 1, 2, 3, 4, 5, 10 is 50. 10, 1, 11.
Alright.
Okay. Let's do a bigger one. What if I had this number? What do you got, Jeff? Sure. 10,193. From Hindu Arabic to baby. So Andrea, tell me, what's the first step in any of these kind of conversion problems?
Find the places.
Places.
So
Keep guessing.
there's try to go to 160 unless you reach a limit to 3,600. And then what's the next one? 36,000 times 60.
Yes, 3,600 times 16.
That's 216.
And do you agree with me that's too much?
That's too much.
I don't need that. The number isn't that big, so I don't need that place. Okay. Now it's incredible. The process is the same. Divide this by 3,600.
You get 2.
You get 2?
Yeah, 2.12. I'm not gonna say the point.
So then how much do we have left? And of course you could just do this in your calculator, right? How much do we have left to take care of? Yes?
How did you get? Okay, different.
So of course,
So
if you do this in your calculator, when you get 2-point stuff, you can either do the little trick we did earlier, or you just forget the stuff. Twice this is this, so I have this much to still take care of. I really want this to make sense. If I put 2 there, have I covered the whole number? No, I've covered this much of it. I still need the other places to cover this much of it. Are we used to thinking of numbers in this way? No, because we're not used to converting to Babylonian numbers. I don't think many of us have done that on the reg. Right? Is that a thing you say? I don't know where the hell that came from. So then 2 of these, and then I just keep repeating the process. What am I going to divide this by now?
By 60?
Yeah, that's the next thing I want to see how much of that can take care of how much of this.
You would get 49.
Sounds right. You gonna try to do this in your head, Jeff? Yes. So that's 2,940.
And
Look at me go. Okay. Yes, 49 times 60 is 2,940. So how much of the number do I have
53.
left? 53. So that'll go here. So that's my middle step. I've got the places correct, and then my last step is get the numerals correct. Of course, is that the only way you can do this kind of problems? No, but to me that's kind of the best process to use. So then what symbols would I use?
the big arrow. And the big,
I need 2.
the 2 big arrows. I don't know how to.
Remember this, I don't know if this is what you're calling an arrow, that's 10. This is 1. So if I put 2 arrows, that'd be 20.
Oh.
And it's interesting, that mistake happened to a lot of people. I don't know what has happened in my 120 class before. Your brain says we're in a bigger place, so it must be the bigger symbol. No, 2 is 1, 1, yes?
You multiply it. Do you?
How do I represent 2 if those are the symbols? If I have 2 of these, it's 20. How do I represent 2? If those are the symbols, how do I represent 2? If 1 stick is 1, what would 2 be?
That'd be. I really thought it would be
That.
that.
This is 10. Do I need 10?
Oh, no.
I need much less than 10. So I can't use this symbol at all for that first thing. What about this one? How many 10s do I need?
The 4. And then you need like 9.
Yeah, so what could you do instead if you wanted to?
Do the T.
So you could do 50 minus 1, or you could do 40. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those both mean the same thing. You guys, yes?
A little line on top.
That means minus.
Yeah, but it's over both of them.
No, so either this place will be that, if you want to use the minus symbol, or that, 49. Right? So this is 50 minus 1,
Oh, okay.
or you can write 49. Okay. And then 53. Nobody wants to use subtraction there, hopefully. That'd be kind of crazy. 1, 2, 3, 4, 5, 1, 2, 3.
I'm not gonna do these as subtraction. I like the other one better.
That's fine. That's beautiful. Nothing wrong. I have no idea if there was like the minus sign camp and the not minus sign camp in the Babylonian civilization? Get away from here, this is our territory, the minus kids. Yes.
How would you know if the place number is 3,600? How would you know exactly?
All right, there's no question. For the Babylonians, they have a base 60 system. The places are always the same. No 60s, which is 1. 160. 60 times 60. 60 times 60 times 60. 60 to the 4th power. 60 to the places are always the same. I think your question is, how did I know to stop here?
Yes.
Or because I went the next one and I realized, oh, that's too much.
That would be too much from the original number.
This can't go into the original number because it's too much.
Oh. Yeah,
Like, yeah, a 3,600 will go into that number. That's why I tell you, because I've had people go here, and then they get some weird shit here, right? If you don't go far enough, you're dead in the water. Yes.
When you're making, okay, 20, okay, it's actually 120 in base 10, and it goes to 20, and we're going to Babylonian from there.
What? Sorry?
Sorry, it's 120 base 10, and then
120.
and then we're going to Babylonian.
Okay.
Yeah. I got 2 over 60, and then 0 over 1 because it's
Yeah.
20.
What's the use
Can
for
you
the?
use the 2 triangles?
Yeah.
That's what I was asking. Yeah. That's what
So
I
that would be no 1s, 2 60s. Is that
yeah,
cool?
that's what I was making sure to do.
Good question.
Oh.
In the other book that doesn't even talk about the placeholder, that problem would be really evil. All right. So I want to do this. I did get internet back, but it's going to take me a little while to find. I want to show you a couple videos. Yes.
The Mayan. I know you wanted to show me a video.
Oh, the
but-
Mayans. Don't worry.
Yeah.
Let's talk about the Mayans real quick.
Because in number in the book it says it's 333.
Wait, L for what number?
11.
11L. Okay, there it is.
And I was
How many places are there? 2.
2.
I like. And again, the book is not exactly that. Like in part K, how many places are there? 2. You guys remember? Yeah, because the blueberries aren't laying flat. So there must be 1, 2. I like it. How many places are here? Part J. There's only 1 place because the blueberries are flat. Yeah, I like it. So I really doubt the Mayans spoke about their numbers. The blueberries aren't flat. But, oh well, too bad. So what's the Mayan places? 1, 20. Good. 20 times 18, 18 times 20, 360. And then you just keep multiplying. Oh shit. Okay. Then they do that by 20 again. 7,200. Yeah, and ad infinitum.
18 times 3.
This is one that I will give you, remember?
Uh-huh.
So I'm going to give you the symbols. You got to know Babylonian base, obviously. But I will give you the Mayan base because it's a weird one. Okay. Now, this number here, number L. We'll go with it, Jen. Number L. Because now we know like B is a number, right? So we're all cool with this. It's got 2 places. And here. You told me this earlier. What's in the 1's place? What is this little crown looking thing? What number is that?
Oh, I thought the little lines are 5.
Good.
And the little berries are 3.
Good. So what number is this?
15. No, I didn't tell you.
5, 10, 11, 12, 13.
13.
Okay. So I got 13 1s. How many 20s do I have? That's the next numeral up.
You have 5, 10, 15, 16.
16 20s. And then you just put them together. So 16 20s plus 13 1s. Do you see that? So again, that's another example of going from somebody else's base to, system to our system is easier because it's just multiplying, adding. Yeah. Or with Egyptians, it's just adding, right? Okay, baby. Oh, I gotta get used to only seeing part of your face, because some of you guys have, like, your eyes always look like you want to hurt somebody. But maybe not. Okay, huh?
Because we're all like serious, like trying to get our stuff done while meanwhile trying to
It's all
understand the
good.
topic.
Does this make,
It
so again,
does-
I'm
it's
gonna
starting to
give
make
you
sense.
this. Right?
It's starting to make sense, just starting,
Okay,
because
now,
can you give us another example of this, like you did with the Babylonian, you know?
well, if we wanna go the other way, that's where things get harder, right?
Mhm.
So what if I had, in Hindu Arabic, I've got 1427. There it is. And I wanna go to Mayan. The places change, the symbols change, but the process doesn't care. The process stays the same. What do I do first? What did we do first when I was going from ours to Babylonian? What did we figure out first? How many places we had to use, right? So let's do that. So I need a ones place, obviously. Do I need a 20s place? Yes.
Yes,
Do I need a 360s place?
yes,
Yes. Do I need a 7200s place?
yes. Oh, wait, yeah, you're right, no.
No. It's bigger than the number, so I can't use it. There, now I've gone too far, so I know I've gone far enough. The only way to really know you've gone far enough is to go too far, to be really sure. Okay. So now, it's so beautiful. I know the symbols are different. That's why in the middle step we do the same thing always. We don't use the new symbols yet. We make this process the same. What do I divide by first, Andrea?
You divide 1,427 divided by 360.
Beautiful. You start with the biggest place. So then whatever the hell that is. It's 3. You're probably, I don't know, Jeff.
You
That could be-
you got 3.
Yeah, Jeff. So if I got 3 of these, 3 times 360 is it 1180? No.
Yeah, you got 180.
1080?
1,080, yeah. Well, I thought you were saying it's
That's right. And so that's 333? Is that right? No, Jeff. If I could just, if I was better at anything. There we go, 347. Is it 347? Well, you couldn't even see it, thank God. Okay.
Yeah, 347.
Okay. Right, is everybody okay out there? You guys okay? It's the same process. So I need 347 left. So what can the 20s do for me?
You can
20 into
divide
347 goes,
that. 17.
17.
Mhm.
And that's 340, right? So then how much do I have left over for the ones place?
That's 7.
7. Is it hot to anybody else? Is it just
No.
me? It's just me as always? Okay.
I'm
Maybe
good.
I'm just hot over here.
Well, the AC is going on over there. You might wanna.
So now we've effectively got the answer in one sense, but of course now I gotta change it to the right symbols. Right, so 3 would be,
360.
no. Now I know that this is the right answer. These are just the places. They're not gonna show up in my answer. How do I represent 3 in mine?
3 little bluebirds.
3 little blueberries. How do I represent 17?
5 lines. Wait.
3 lines.
3 lines.
3 lines, 2 blueberries. Right, 15 plus 2. So really mine's all about what multiple of 5, and then the blueberries are the extras.
And seven blueberries, or maybe 1 line and 2 blueberries.
There you go. Kick ass. So just like our system, is that really 3? does this really mean 3? No, it means 3 of these. How do we know? Because that's the place it's in. Does it look like our system at all? No! Does it act similar to ours? Of course it does. Because they're both place value systems. They're both based on place.
I have a question, but not about Mayans or anything, but when we get to bases.
Sure. Yeah, it's a great segue.
Oh, I have one more
Well,
question.
okay. What's up?
One more question. I'm not gonna be here on Tuesday, so do I just give you all my homework when I come back, or?
Oh, you're not here Tuesday.
Yeah, because of the ARC testing.
Oh, that's right.
I'll be
You
at
could
home.
drop off in the classroom before you start, but it depends on what time you start.
I can't,
Otherwise, just give it to me next time you see.
yeah, I'll do that.
What was it again? I'm sorry.
The question about bases.
Oh yeah. So like base 7 and stuff.
But here's my problem. Let me get back to the page. It's in 2.3, but it kind of raised the bases. But it's 12 base 5, and then it goes to base 9. But I got 7 base 10. And then I converted that, but I don't know why I haven't.
All right, now watch. This is so cool. All right, you would say that, Joe.
Fancy.
3 base 6 is equal to what base 5? Jeez, man, you are really crazy. Holy crap. Okay, maybe that's better. Can I put my hands there? Yes. This is such a weird question. 3 base 6 is what base 5? What does 3 base 6 mean? What place is 3 in?
1.
The 1's place. So doesn't it just mean the number 3?
Yeah.
So what is it in base 5 then? 3. 3 base 10 is 3 base 9 is 3 base 8 is 3 base 7. They're all the same because they're all just singles. What's the same thing across every base? What do they all have in common? The 1's place.
Okay.
Right? Now, of course, I couldn't ask you. Now watch this. So this is 3. Does everybody understand that?
Okay.
Because it's just the 1's place. Nothing happens with the 1's place until I ask you
If it's
3
7
base 6 equals what base 3?
Yeah, you would need another place value.
Right? I can't use the number 3. So now, this is a 1's place, but I'm going to need 2 places for this base. Because I can't have the numeral 3. And just remind yourself, what's the highest numeral in base 10? The highest single digit? 9. So that's true for every base. If I'm in base 7, the highest single digit is 6. If I'm in base 3, the highest single digit is 2. So can I put a 3? No, it doesn't exist in base 3. Yes?
So would you put a 1 0? Would you put a 1 0?
Yes, because now the bases in the places in 3 are 1, 3. So I'd have 1, 3, no 1s. So this would be 3 base 6 would be 1, 0 base 3. Okay, those are really interesting, weird little things. I want that to make all the sense in the world. The 1's digit's awesome until the base system gets too small. And oh shit, you need more places because you ain't got as much to work with. Okay, that was neat. All right, is that all right? Anything else about that?
So I know that for 12A, for Roman numeral, which I already translated to, would be 824.
All right, wait, let me catch up to you.
It was in 2.2 set A. For my next place number, what would it be in the Mayan's place? I know it's 120, 360. How did you get?
Wait. We're talking about this one here?
Yes.
So change that to our system.
Well, I'm talking about A.
Oh, A. So why are you saying Mayan? There's nothing up here about Mayan.
Well, Babylonian.
Babylonian, okay. So you change this Roman to what'd you get for our system?
824.
824 sounds right. Now it's almost like a 2-part problem. That was one problem. Now change this to Babylonian. And you know how to do that because we were just doing those kind of problems, right?
Mm-hmm.
So I really want you to understand. This is a 2-step process. It is 2 problems in one. Don't feel like you're missing something if you're not able to do it in 1 step. If we were a Roman student and we're in Roman times, right? And our teacher is teaching us about the Babylonian number system. we would learn how to go straight from this to this. Does that make sense? But we're not. So shit, we got to go to us and then go, oh, now I can do this. Andrea, is that cool? Like, we're telling you this is a brand new problem. Take that to Babylonian, you write the places, you go as far as you need to, you start dividing, right? Just like we were doing earlier.
Because I know that I divided 824 by 60, I got 13. But of course, I have still more places to go because I know I can't go to Dixon.
So you got 13 here?
Yes, I have 13 there.
And what is that? When you do 13 times 60?
13 times 60 would be 780.
Good. So how much do you have left to take care of?
That would be 44.
So then that's what goes here. And now you just got to change it to the Babylonian numerals, right?
How would I make it? I know that 13.
No, not all you got to do. 13 is 10 and 3.
So
What's
that's
10?
The little arrows.
The arrow. So you have 1 arrow and then 3
And 3 little triangles.
sticks for triangles. I like the carrots. 44. 4
4 of the arrows.
and then 4. Yeah. Okay. So let me do this. I've got something. I focused on chapter 2 on this because I already told you what I'm going to put on there from chapter 1. So if you weren't here last time, I'm going to give you a problem like little Billy tried to do this. Can you explain to him why that was a bad first step or something like that, right? And then I might ask you, can somebody tell me? I did this last time. What are some of the strategies you could use? Draw a picture. Draw a diagram. Draw a picture. Guess and test. Use a variable. Make a list. Look for a pattern. Right? Those kind of things. So I might ask you something like, list as many strategies, or I might say, what's the difference between this strategy and that strategy? I don't know. Right? So I'm not going to give you a problem because, again, that wasn't the point of chapter 1, and I feel really bad that I didn't make this clear. The point of chapter 1 is getting used to the processes, right? Not, can you figure out the damn train? And if you can't figure out the damn train, you fail. That's not the point, right? Okay. So this is just a practice test. And the formatting is freaky because I kind of Frankensteined it together. So there will be all this set stuff on there. So that's the front. And then there will be conversion stuff like on the back. So I don't mind if we can do this any which way. You guys can start working this yourself, and I can kind of check in. We can go over some of this together. You can work on this together with each other. I want to make sure that you know all the answers to this before you leave. If we don't get all the way through it, maybe I'll post a solution to this or whatever. Yeah, but this is just
For us.
the kind of problems I would be giving you. I'm going to give you some wordy problems. I'm going to give you some visual problems. Right? I'm going to give you like number 5 is going to be neat. I'll let you look at that one. I like a problem like number 5. I would.
I like number 7.
Whoa. Oh, okay. It's cool with me. All right. So it's really up to you guys. However you want to, you can work with each other. You can kind of do a few of them alone and then check in with people near you. I'm going to have that on the test. So on the test, I'm going to give you the symbols, and I'm going to give you the Mayan position, right? Mayan-based places. Oh, that's right. Oh, that's okay.
Yeah.
How do you mean by itself? So here's how I would answer. Oh, I see. This one, I have to know what that is, and I have to know what that is, and then I can intersect them. This one, if I know what that is, this means everything that's not in there. Yep. So here's your universe, right? That's everything that could exist. So figure out what A and B is, and then this means everything that's not in A and B.
You know that this one?
This would be, it could be in, it's gotta be in not A and not B. So you have to first figure out what's not A, what's not B, and then you can just see. See, right now, would it, if I did A and B, isn't that an easy question? Because you can see A and B. If you wrote next to this not A, not B, then not A and not B would be an easy question too. So that's why I say construct the parts, because then you can just look at them the same way you do with these.
Oh. But it's not another one.
I guess I don't need to record this part.